Now for part 3 on answering FRQ questions. We've got our FRQ question 1. We've already answered parts A and B, and now we're going on to C and D. So here's what it might look like on a FRQ booklet. My guess, though, is probably they would have this spread over 2 pages. And it's one that switches because we sort of go to a new topic, which is not unusual even within a single FRQ. So let's focus on this question and see if we can answer it. There are probably about 4 points, so you think roughly 8 minutes to solve both C and D, 4 minutes for each. So we've got a student, and they learned that calcium hydroxide produced in that last reaction is relatively insoluble, and that it dissolves in water according to this equation. So we've got a solid dissolving calcium ions and hydroxide ions. The student prepares a saturated solution to reach this maximum solubility and determines that the calcium ion is 0.011 molar. Calculate the value of the KSP for the calcium hydroxide. A solubility problem, definitely. As such, we should deal with the expression that involves our KSP. Our KSP is going to be equal to, forget about the solid, the ion, raised to the power of their coefficients. It's going to be the calcium ion concentration, which they give us, which is nice. We've got half that equation. And then the hydroxide ion concentration, which we just have to square. Now, they didn't give us the hydroxide ion concentration, but that's going to be pretty easy to figure out because you know that this is a coefficient of 2, and for every 1 calcium, you get 2 hydroxides. So quickly putting that in fact, I'll do that so I'll just take my 0.011 and multiply it by 2, realizing that that's the concentration of the hydroxide ion. I have to calculate the KSP, which all we need to do is plug the numbers in. Again, your calculator. I'll just square that last answer and then multiply that. You don't have to put the multiplication sign in, but I'll put it in anyway. 0.011. Double check things. Yes, I've got the decimal points right. 1. My answer 0.022 squared. Nothing else to deal with. And come up with my answer of the solubility product. It's relatively low. 5.3 times 10 to the negative 6. I'll pull my calculator up again and double check it. Yes, 2 significant digits is fine, but if you showed 3, good too. I'm not sure they give you a check mark for this if you got just 1 significant digit, because it's not close enough to show what the solubility is. So let's see what they decided on the scoring for this. And you got 1 point for showing the concentration of the hydroxide ion. Just 1 point for that, which just takes a couple of seconds. Now, if you had that within your calculation, showing your work, they would have recognized. If you had a 0.022, then they'd realize that you knew the hydroxide concentration was double the first. But you could pretty well figure out that they wanted you to do that because that was sort of the hidden part of the problem. They didn't give you the hydroxide ion concentration. 1 point for the correct value for the KSP of this. You'd have to get the right answer. We can move on. Now let me double check. This is low solubility, so we got a small KSP. Did we answer the question? Calculate the value for the KSP for calcium hydroxide? Yes, we answered it. We go on to the next part, smiling. This would give us, right now, if keeping a running tally, 8 out of 10, 80%. That's a 5 without doubt level on FRQs. Let's see if we can get a perfect score. It'd be 1 out of 100,000 to get a perfect score on the FRQs. A student wishes to significantly increase the molar solubility of the calcium hydroxide and has access to the following things. Okay, water, calcium chloride, calcium hydroxide, HCl. Which substance, when added to the calcium hydroxide mixture, would increase the molar solubility? Which would have us increase the amount of calcium hydroxide that dissolves per liter? Justify your choices based on the concepts of chemical equilibrium. Well, here we've got our KSP, and we want to increase the amount of calcium that we dissolve, calcium hydroxide. Now, if we add water, yeah, more calcium hydroxide will dissolve, but per liter, it's still going to be saturated eventually. So that doesn't really increase it. Calcium ions soup up this calcium concentration, and that'll prevent more calcium hydroxide from dissolving because we've got this equilibrium expression. That's what we want to look at. We want to look at this equilibrium expression. And if we increase the calcium concentration, the reaction will shift backwards and we'll get less calcium hydroxide dissolving. Same thing for the OH. If we increase hydroxide concentration, that's going to end up shooting things backwards because these are 1 molar concentrations. That leaves HCl, but you say, what does HCl have got to do this? Well, an AP chemistry student would know that HCl is a strong acid. You've memorized them, and if you decrease the concentration of your hydroxide, the reaction using Le Chatelier's principle will move forward. So there's our choice. So let's give our answer, and you should write down HCl. Now you could write down 1 molar hydrochloric acid. This HCl here is what you want to end up having somewhere in the problem. The readers are very careful, and even if you don't circle your answer, if they see HCl as your choice, they will give you the point for it. Of course, the justification is the next part that you have to worry about. This justify. Why did you pick this? You get 1 point for picking the right thing, and then you get another point for saying why. So you've got to toss that in. There are a number of different ways of doing this, and the heart of the reaction is the HCl reacts with a hydroxide ion, decreasing its concentration. You could invoke Le Chatelier's principle, or you could go on to end up saying that with the concentration of hydroxide lowered, our Q, our reaction quotient, is too small, and then the reaction will move forward to try and get up to the KSP again, where we end up getting both materials multiplying out to make the KSP we have. Either one of those would end up working. And again, notice it's not a very long set of answers. It's pretty short, and you end up getting 1 point for the justification, and you get 1 point for choosing the HCl. Both of those. Notice sometimes the second part of or a question can be totally independent. You didn't have to look at page 1 at this at all. You had a totally different question. This isn't thermo, this is KSP. And don't give up on a question if you have difficulty on A and B. Keep on going. There's going to be some other things, and I find sometimes that the last part of an FRQ can be easier than the starting part. Okay, we've answered this. We've got our 10 points, which is amazing. Like I said, just getting 8 points on this would be a winner. Let me just bring in a little bit because we're talking about calcium hydroxide, and it's very often called lime. You'll be surprised how many foods have got lime in them. The most prevalent one here is any type of food that has cooked corn in it. If you've got something that's using corn flour, you'll find out that the corn was treated with calcium hydroxide, this lime stuff, which is basic. But this calcium hydroxide is added to corn for a very specific reason. You've got corn. Now, not corn on the cob, but the classic tough corn stuff, and you're going to use it for food. You're going to grind it up. It really is a tough material to deal with. It's very difficult to grind into a flour. And then one of the interesting things is it doesn't provide sufficient nutrients. If you just try and live off of corn, you're in trouble. But if you add calcium hydroxide to it, this basic solution is just basic enough to weaken these kernels of corn and undergo a process that is tough to pronounce, nixtamalization. And what happens is that lime water, which is the calcium hydroxide, breaks up some of the starches and releases some very important nutritional materials to it. And with that, when you end up having this, you get enough of the nutrients that you need to allow corn to provide all the amino acids that you need. In this case, the important one is niacin, which is locked in that you would not normally get out of corn. This corn that you get after this has been soaked and warmed is different. It's yellow. These little skins come off. They rub them off, and then you can make a flour that is a very healthy food. So you want to have some lime in your corn flour that you use for cooking. This was found out in Latin America probably 3,000 years ago. When corn was harvested and cooked, they took some ashes, which have lime in them, and roasted limestone. And when you mix them together, you've got yourself very nutritional food. Okay, we've answered an FRQ and found out that if you need to live on with corn, take some limestone, heat the heck out of it to get lime out of it, and then boil that corn with that lime. So, good advice for FRQs and nutrition.